Okay, 7C continuing, number 19. 19 is insurance claims. The policy sells for $1,000, and based on the past data, the average of 1 in 50 policyholders files for a $10,000 claim, an average of 1 in 100 for 25, and an average of 1 in 250 for 6,000 claim. Find the expected value to the company for policy sold. So they're going to get plus $1,000 100% of the time. They're going to lose a $10,000 1/50th of the time. They're going to lose 25,000 1/100th of a time, and they're going to lose 60,000 1/250th of the time. And so if you work that out, let's see, let's just get let's just do that on the calculator. So we get 1,000 minus 50 into 10,000, 55 in there is 200. 100 into there is 250. And 250 into 60,000, I should know that, but 60, divided by 250 is 240. So 1,000, 800, 6, 550, 510, 410, 310. So the insurance company per policy is planning on making about $310. So if the company sells 10,000, what's the expected profit or loss? So if they sold 10,000 policies, it'd be 10,000 times this, which would be 310,000. $3,100,000 they expect to make. They can sell 10,000 policies, and those are the projected expenses. Okay. Number 27. 27 says coin streak. You toss a coin 1,000 times and record the results. You got 10, and you find that you got 1 point. You got 10 heads in a row. What is the probability of getting 10 heads in 10 tosses? Okay. So the chance of getting a head is 1/2 times again a head be times 1/2 times again a head 1/2. So it's really 1/2 to the 10th, which is 1/1024. So you should get 10 heads in a row once in every 1,024 tosses. So if you've got to toss it 1,000 times, it's likely you should get one row streak of 10. So it's likely to get at least one, get somewhere around one. So it's somewhat likely. Okay, 31. 31, so Powerball, they give you this, and state how much you expect to win or lose if you played 365 times. So to do this one on 31, the jackpot is 30 million. So you would go through and do each of these. 30 million times the probability, which is 1 divided by, and so we can just do it by divided by 175,223.10. That's how much. Let's just see what that is. So if the Powerball company put 17 cents aside of every ticket sold, $1 ticket sold, that would cover the 30 million for the jackpot on that. But then they have to put away some money, so plus they have to put some money away for the $1 million winning, which happens divided by 5,153,633. And then they have to put some money aside for the $10,000 winners. 648,976. Then they have to put some money away for the $100 winners. 19088. Plus they have to put some money away for another way to win $100. Plus you can win $7. Plus you can win $7 another way, and that's probability of 1 out of 706. Plus you can win $4 111 ways. Plus you could also win $4 and 55 different ways to do that. So if we work that out, every ticket they're going to set aside 53 cents, 53.21 cents, 22 cents to cover all the payouts. And so the rest of it is all goes to you. So they're going to pay that much out, so they'll keep the rest of it. And so if they're getting $1 minus the amount they pay out, they're going to keep 46 cents, 47 cents approximately for each one. So then state how much you expect to win or lose if you play 365 times. Well, if the Powerball company gets that much, then you're going to lose that much. And so we'll take that times playing 365 times. You expect to lose about $170.75. Okay? Now, what if it was only 10 million for the jackpot? Well, then you're going to lose more. So let's go back here and go back up here to where I had the answer. And I'm going to delete that and put in insert a $10 million jackpot, 1,0,0,0,0,0,0 divided by, and that was the jackpot is 175,223,510. And so they will expect to get 41 cents, 42 cents. So you expect to lose 58 cents, and if you play it times 365, you're going to expect to lose $212. So 32, you're going to expect to lose $212.41 over the year if you bought one a day. So somewhere between $170 and $212 you'll expect to lose if you bought a Powerball ticket every day for a year. Okay? So you spend 365 and win 100 and something, but end up losing overall. 30, I didn't ask you to do 32, but I did it for you. Now let's do 34. 34. Mega Millions. So 34, you would do pretty much the same thing as I did 31 and 32. You just have to divide by different numbers. So I think if you look at 31 or 32, you'll understand how to do that one. And then 37. 37, household size. And this one it says 57%, so probability of 0.57, that you come from a household of 1 or 2 people. And it says in the problem, use an average of 1.5 people in those types of households. And then it says there's a 32% chance, so 0.32 probability, that you come from a household of 3 or 4. And they say use 3.5 for that number, the value, and that's the probability. Plus then it says 11% come in 5 or more, and so that's 0.11. And they said use, for the 5 or more, use 3 or 4 and 6 for the households of 5 or more. So 6 people on average from the households of 5 or more. And what's the probability that any particular household will have how many kids? So 1.5 times 0.57 plus 3.5 times 0.32 plus 6 times 0.11, and we get average household 2.635. Okay? And that's the households that have kids. Now, these mean household size. Okay? And that was the last one.